My name's Greg Darcy. I'm part of the team that works on the Social and Cultural Informatics platform at the University of Melbourne. As part of this short tutorial today, we're going to talk about tidy data. So doing research involves working with data. And whether you're using more traditional methods or whether you're using digital methods, most researchers nowadays are tending to work with data in some digital format. As researchers, cleaning data and creating analysis data sets is often the most tedious and time-consuming aspect of their work. Now, within this context, data obviously comes in many forms, but we're pretty much focused on tabular data. Think CSVs and spreadsheets. But don't take my word for it. So looking at this Kaggle survey from 2018 with over 23,000 data scientists, found that 40 to 45% of their time went in simply to cleaning and preparing their data before they even commenced any further analysis or work on it. So the focus of this tutorial is we're looking at tiny data. This is about changing, not just cleaning up your data, but changing the organizational structure of your data. Why is this important? Well, so obviously, as we hit on before, to save time, cleaning and preparing raw data to prepare a data set for analysis. Saving your process aids reproducibility, so you can easily repeat your analysis if your data set changes or you have more data sets to add to your research. Also, too, getting into a habit of storing your data in a consistent structure means it's easier to learn a uniform set of tools to work with that data, as opposed to having to literally reinvent the wheel and start from scratch every time. So the aims of this tutorial is we're going to look at the underlying principles of good data practice in data organization, understanding the concept of tidy data and the functions from the tidyr package, which is an R package, and finally hopefully understand how learning some basic programming skills in the long run will make your life much easier. So let's talk a little bit about cleaning data. I first started using R myself not that long ago when I was working with a researcher who was basically recording information from archival records, so different archives, libraries, and wanting to record some of the information they were finding in some of those registers and looking to plot the information that she was finding onto some sort of map to visualize the data. It became evident pretty quickly that because it was very much a manual process of her recording the information from different archival records she found, that the propensity for error creeping into that data entry process was quite high. So in terms of the data set, it wasn't a huge data set. It was pretty much just at the start of her research. But what was clear was that in terms of being able to identify a number of street addresses that could then be geolocated and displayed on a map, there was a fair bit of cleaning that had to happen up front. So there was quite a few spelling errors, as we can see there. Street was spelt quite differently. There was abbreviations to streets, roads, that kind of thing. And then a little bit more detail, just general ambiguities. So the original document, rather than specifying a particular street, might have said something like the corner of Albert and Buckley Streets, or even not distinguishing between whether it was a street or a road. So there was a lot of pre-processing that needed to be done on this file before it could actually finally end up in some sort of mapping application. So what do we mean by untidy data? Well, this concept is something that we'll look at that was, I suppose, first put forth by a statistician called Hadley Wickham, who's developed a suite of R packages called the tidyverse. So when we're talking about cleaning up data or dirty data, we're really looking at things in terms of fixing up errors, such as we just looked at, removing duplicates, maybe syntax errors, get some standardization. Obviously, you might often find in a data set a lot of variation with how something like a date is recorded, or even a number, and of course missing values. Now this is basically cleaning up the data set, but we're also going to have a look at the structure of how data sets and how they can be created to really help your analysis. Quite often we'll look at some tables really that are really created, I suppose, to favor presentation or to favor data entry, but can actually be improved to make your analysis a lot easier with these types of tools. So, tidy data, what is it? As I mentioned, the tidyverse is a collection of R packages that all work together to do a specific function. Some clean, some process, some visualize data. This was a package with quite a strong community behind it, initially created by Hadley Wickham. And the one that we're particularly interested in today is this tidyr. tidyr is a package that makes it easy to restructure your data so it's in a format that is easier to use. So by tidy data, we mean data that's usable for analysis and data that's easy to model, visualize, and aggregate. So there's three interrelated principles for a tidy data set. Those principles are that each variable exists in its own column, each observation is recorded in its own row, and each value is in its own cell. Now that kind of sounds a bit obvious, but as we'll kind of go through some examples, the way data is often put together, and this may be data we create ourselves, our primary data, or it might be secondary data we obtain from somewhere else, isn't necessarily structured in such a way that's going to lend itself to analysis. So let's look at a simple example. So as we can see here, we've got a number of blocks. Each observation is data about a coloured block. And so if we look at these blocks and we want to consider these as a data set, there's three variables. We have shape, colour, and frequency. So if we look to the right there in terms of our table, under shape we can see each observation. We're only dealing with cubes. In terms of colour, there are a number of variations in terms of the colours that exist. Frequency, well, in this instance we've the only difference is that we have two red cubes with the remainder being one. But you can see here we're following this principle that each observation is quite separate and each column is its own particular variable. Common causes of untidy data. Common problem is a data set where some of the column names are not names of variables themselves, but values of a variable. So what does that mean? One of the great things about the way they put together these tidyverse packages is that, as well as a lot of functions to help you work with your own data sets, there's pre-built data sets that already come with it, which are really great to prize apart and see how they work. So they're great examples. So this is one of the data sets that comes with the tidyr package with the pithy title Table 4A. So the issue here is that we see that I think we're only looking at the first few columns here. Actually no, sorry, it's quite a small table. But we'll see here in those latter two columns, 1999 and 2000, are actually years. And within each of those categories, what's contained are those numbers are actually cases. So again, we're looking at an instance here where the column names are not variables themselves, but the values of a variable. So if we think of the variable as year, the two values ideally are 1999 and 2000. So tidyr comes with a function called pivot longer. So what we want to do is be able to restructure the organization of our data set. So what we've done here is we've said, okay, for table 4, we're going to use the pipe function. I want you to use pivot longer. I want you to take these two columns and I want you to take those and create a column name of year and create the values. It's a little bit cut out there as to cases. So all the values in years are shown under cases and the column names are displayed as individual years. So when we have a look at that, this follows along the principles of tidy data, that we've now got a longer data set than we had before, but each one is a unique observation and also more in not ideal for display if we were presenting it, but in terms of analysis, we can see that each one's quite unique. That each observation we have a country, a particular year, and a number of cases for that year. So what we have now is table 4, but it's in a longer, tidier format. So the column names 1999 and 2000 represent the values under the year variable. The values in 1999 and 2000 columns represent the values of cases. So each row represents 2 observations, not just one. So the next scenario is almost the opposite of what we last looked at, and that is where, as you can see here in the case of this table, an observation is scattered across multiple rows. So this is another data set that comes with tidyr, but in this instance the observation is a country in a year, but each observation is then spread across 2 columns. So we can see that there's 2 types, cases and population, and a different count for each of those. So the pivot wider function enables us to do the opposite of what we did earlier, and that's taking that longer data set and turning it into wider format. So what we can see now is a bit more coherent again, coming back to that principle of each row being an observation. We can see that each row has a country, a year, there's a value for the number of cases and a value for the population. So we use that function to pretty much just restructure the columns and tell the tidyr package where we want the new values to come from. So pivot longer makes wide tables narrower and longer. Pivot wider makes long tables shorter and wider, as we can see there. 2 more handy functions that are quite commonly used in the tidyr package are separate and unite. So separate, we can see here pulls apart one column and splits that into multiple columns. Now it does that by wherever it reads a special character. So we can see here in that rate column for table 3, the special character is a /. Basically within that function you could depending on the data. It could be a full stop, it could be a comma, hyphen, whatever, but it will basically split the rate cell and send that to two new variables or columns that we choose. Unite does the opposite. So Unite combines multiple cells into a single column. So as we can see there, in this instance on the right, century and year are combined together into the one column called year. So we covered a little bit of ground there. Let's just quickly recap. The benefit of working with tidy data is to ensure your data is correct and consistent, usable for analysis. It involves that process of using the tools to clean your data to fix any errors or missing values. But as well as cleaning the data, creating data sets for analysis can require restructuring the organization or shape of the data set. So the principles of tidy data that will help you with that is that tidy data has a consistent form, again, where each variable goes into a column and every column is its own variable. Where to from here? Definitely would recommend downloading RStudio. It's open source, it's free. It's a good way to use some of the code, some of the examples. I had the URL earlier from Hadley Wickham's online textbook. You can literally cut and paste some of the code blocks straight into RStudio, and you're off and running very quickly. Now, really, we just looked at, I suppose, processes that will save you a lot of time, but I suppose it's just very conceptual in terms of restructuring your tabular data. I suppose the exciting part is when you can start to use that data to plot and visualize, do some exciting things. So go and explore. As I mentioned, these packages already have their inbuilt data sets for you to trial and play with before you start incorporating your own. There's also a lot of really good online courses out there. Basecamp, I definitely recommend Data Science with R from Danielle Navarro is a fantastic resource. And again, I think the link there, R for Data Science, is Hadley Wickham's book. The RStudio community itself has created a lot of resources there that'll really get you up and running very quickly. Thanks for listening.